Okay, so one of the first things that we've got to talk about when it comes to energy, because we're going to talk about energy and then agriculture, and we'll kind of talk about climate change and resource mining and pollution along the way. So on the weekends, first today we'll talk about math, like the mathy side of stuff, which is good because there's a lot of math with the energy stuff, but we also kind of need a little bit of context today, talking about mathy stuff. So first, let's talk about energy. You can kind of break it into two categories. There's non-renewable and renewable. And we've kind of talked about these before a little bit. What, for example, is a non-renewable energy source?
Coal.
Coal, yeah. What else?
Oil.
Oil, yeah. What else do we use for energy that might not be renewable?
Wood.
Wood. Well, hold on a second. Is wood a renewable resource?
Yes.
What?
Really?
It's trees.
But if we burn your... Okay, it's
True.
just not sustainable.
Yeah, if we don't do it in a sustainable way, then it becomes non-renewable. So maybe we'll put a little star there. Okay. What's another maybe fossil fuel that we use? Coal, oil. Ooh, okay. Natural gas. Do you guys know what I mean by natural gas? That's usually when we talk about natural gas, we're talking about like methane, propane, butane.
Did you say cocaine?
No,
You
butane.
Yes.
know nobody thought she said cocaine.
No, I'm
What do
being
you
serious.
do on the weekend?
I thought she said methane, cocaine, butane.
No, propane.
Okay.
Okay, so coal, oil, natural gas, and another big one is the stuff that we use for nuclear energy. So stuff like uranium, plutonium and stuff like that, but uranium's a big one. So we'll talk a little bit more about on Monday about where coal comes from, oil comes from, natural gas, uranium, etc. And we'll talk a little bit about how they make energy. Okay, what is a renewable source of energy?
Water.
Water. Now, when we say water, there are a couple ways that we can make energy from water. Do you guys know what they are?
Dams.
Yeah, hydroelectric dams, hydroelectric dams, which we in the Pacific Northwest should be very familiar with. The Columbia River is one of the most dammed rivers in the world. I believe it's got, I can't remember if it's 6 or 8 dams on it. Now to have, there's a reason why the Columbia River is dammed for hydroelectricity and why the Mississippi, for instance, isn't. Anybody have any idea why?
It's not large enough.
No, Mississippi's huge. Way bigger than the Columbia, too.
Too many species of animal.
No, that's a good guess, though.
We don't care about the animals.
It doesn't have to do with pollution necessarily.
Too windy.
The Mississippi's fairly straight compared to the Columbia.
Is it because of
Location.
Is it because they don't need it?
No. It's because the Mississippi doesn't really cover as much of a height difference as it flows from, we'll say, Minnesota all the way down to the Mississippi Delta. There's not much of a elevation change. Whereas with the Columbia River, starts off in like northern Washington, right? It starts out in the mountains. Okay, and as it goes, it picks up more and more and more water through other mountain streams and stuff like that. There's a huge difference in elevation between where it starts and where it ends. And that elevation change is what allows hydroelectric dams to work. That's where you get your energy. Think back to FPC and physics, if you took physics. You need a lot of potential energy difference, so height. Remember potential energy, I got it written over there, is for most objects, it's mass times the acceleration due to gravity times height. So height is the big thing there. The higher you are, the more potential energy you have. Now, if you have a lot of potential energy, you can turn that into kinetic energy. That kinetic energy turns a turbine, which turns a generator, which produces electricity. It turns it into electrical energy. Okay? So that's what you need to make a hydroelectric dam work. But there are also seawater generators. There was actually one, they just shut it down. They were going to build one off the coast of Reedsport, and they're abandoning the project. It was really expensive. But there's ocean generators. They're also called wave generators. Okay, so those are kind of the two big water ones. Is hydroelectric dams and ocean and wave generators. So water, wood. What else is a renewable energy resource?
Wind.
Wind.
Solar power?
Wind, solar, and there's one more big one. And I don't know if you guys are going to get it. It's geothermal. Do you guys know anything about geothermal energy?
It's from under the ground.
It is. It's from under the ground.
Does it have to do with volcanoes?
Kind of, yeah. There are certain places in the Earth's crust where there's either a vent or the magma and stuff is very close to the surface. And so where you would find hot springs, that's a lot of geothermal activity.
Like in Yellowstone?
Yeah. And with Yellowstone, the magma is very, very close to the surface. And so I don't know if they do it at Yellowstone. I don't know if they do or not. But in places kind of not as, maybe not as active. Because Yellowstone is actually a giant volcano. It's called a caldera volcano. It's very shallow, but those ones tend to be the big ones. So anyway, if that thing went off tomorrow, we'd all be dead probably within a short period of time. But we won't talk about that. Not today anyway.
There are plenty of movies out there if you want
Oh
to
my
see what
god!
would happen.
And they
I was kidding.
2012. I
Oh,
could
that
just
movie.
that movie needs to be thrown in the garbage.
I could
forever.
not watch
Should
it.
happen.
I hate movies where the only point is to stress you out about things that could happen.
Yeah.
But they stress you out about things that couldn't happen too.
Yes.
The first year that I taught Earth Science here, the final exam was you had to find 3 of the many Earth Science inaccuracies and debunk them. So for instance, like
That's funny.
all the glaciers melt, right? And they show like water lapping up against the sides of the tallest mountains, like in not Kilimanjaro, Mount Everest, right? So these people are at the top of Mount Everest, and it's like, are you serious? Do you really think that there's that much water that it would go all the way to the top of Mount Everest and somehow leave parts of South America intact?
Huh.
I digress. Anyway,
Watching this video.
geothermal, basically the way geothermal works, and I'm going to put a little red dot next to these ones that work this way. Coal, oil, natural gas, uranium as in nuclear, geothermal, some types of solar, so I'm going to give it like a little half circle, and some types of wood, energy, so another half circle. All these ones that have a red dot on them, one of the ways that they work, for instance with coal, we burn coal. And the reason that we burn coal is because it produces heat. That heat heats up a liquid, usually some sort of water-based liquid. And what happens is you have an elaborate piping system, and that water heats up, it creates steam. Steam rises, turns almost sort of like a fan, which I'll call a turbine. That turbine turns, and as that turbine turns, it creates electricity through a generator. You guys remember this from physics or FPC? Okay, so that's kind of the way it works, is heat goes into heating water. That water turns the turbine, because it heats up, creates steam. Steam turns the turbine. Turbine turns the generator. That produces electricity. That's exactly how coal works. In countries that burn oil, not like as in gasoline in a car, but to burn oil, that's the same way that they do it. With natural gas, that's how natural gas works, is it heats up water, which turns the turbine. Nuclear, that's exactly the way nuclear works. And people sometimes get really freaked out because they'll have like a nuclear power plant, right? And imagine those things from like The Simpsons, right? And then there's this like this steam coming out of the top. Everybody's like, oh my God, they're venting nuclear radiation. This is why you need to take this class. It's because they're not venting nuclear radiation.
Chernobyl.
They heat water, which creates steam. Okay, steam builds up pressure. Sometimes they have to vent that steam to release some of the pressure. Okay, so they're actually venting steam. So this is as toxic to you as a cloud, like in the sky right now.
Well, that can be pretty toxic.
Huh?
That can be pretty toxic. What about acid rain?
Oh yeah.
When was the last time that killed somebody?
Yeah, acid rain takes thousands of years to erode rock.
Yeah.
Does it?
Or like
Yeah.
some time to erode rock. It's usually, acid rain is nasty for amphibians and water-based creatures.
But for
Also
us-
bad for masonry, so marble and brick surface buildings.
There you
Not
go.
gonna kill you and me. So acid rain, not a big.
At our
problem
girls'
for humans.
School, we give them, we tell them it's limestone and acid rain, but it's actually just those thing volcano.
Pumice?
When you make a 6th grade volcano.
Oh,
with,
baking soda.
Yes, and vinegar, and we put it in their hands, and we tell them that it's limestone and acid rain, and they all freak out. And consistently, they will all tell you it burns their hands every time.
Really?
It's hilarious.
They're like, oh,
Every single time.
They're fake.
Burns.
No, it doesn't.
No, it doesn't.
Oh, kids, they think what they want to think, don't they?
Anyway, that was a tangent that needed to happen.
Anyway, with nuclear, they have that nuclear reaction going, and they regulate the temperature, so just enough heat is created to boil the water, which creates steam, which turns the turbine, which creates electricity in a generator. So that's the same way that nuclear works. Geothermal, same thing. Solar, with some solar, especially the older types of solar, it would heat up the water. So the sun, the heat, the thermal energy from the solar panel as the sun beat down on it, which means you had to have a lot of heat. Like in this particular part of the country, you don't want a water circulation solar panel system. My father-in-law, my in-laws have it on their house in St. Helens. Didn't produce a whole lot of electricity. For that reason, like in Arizona, having that water type is fine. Here, not great. Now there are other types of solar panels where they take direct photons from the sun. So right now there are photons coming through the clouds and stuff, so it doesn't need to be cloudy or particularly super sunny. You can still get those photons. Those photons hit the panel and directly produce electricity. With this older style solar panel, it would circulate the water, and that water would basically turn a turbine, which would turn a generator and create electricity. Okay, wood. You know that if you put wood in your fireplace, it's not boiling water. But if you had wood and under the same sort of guise, I'll say biomass. Have you guys ever heard that before? Biomass? Let's say we demolish a building, or we've got leftover stuff on our fields. Like, for instance, I've just harvested all my corn. I have all these husks. If I leave those husks there, it might attract mold and bacteria that I don't want affecting my future crops of corn. I want to get rid of this stuff. Sometimes you can burn biomass. Here, actually, I'm going to put this as a different one. Biomass. You can burn biomass, and just like I said, you burn the biomass, it produces heat, heat creates steam with this water, the steam turns a turbine, creates energy. Okay, you can do biomass that way. Also, so this one gets another little half one. Another way that you can use biomass is have bacteria break it down and create natural gas. And then you take that natural gas and burn that, and it does the same thing. Heats water, turns turbine, blah, 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 blah. Okay, so what is a common theme with most of these renewable and non-renewable energy sources?
Most of it has to do with heat.
Turns a turbine.
Has to do
With
with
the-
water,
With the ones that
heating
are
water.
red.
What about wind?
Now wind is turning a turbine, which is turning a generator, which is producing electricity, but you don't need water for it. Okay, and water with this hydroelectric dam and with the ocean, it's water, but we don't have to heat it up. The water is just turning a turbine. So that's where that potential energy is needed. You've got you've dammed the river, and as it falls and it goes through the dam, as it goes through the dam and as it goes down through the dam, it turns a turbine, which turns a generator, which produces electricity. So the common thing here with most of these is you have to turn a turbine, which turns a generator, which creates electricity. Almost all of them, except for certain types of solar, do that. So that is why you guys learn about it in FPC, or you should learn it if you took my FPC, that if you turn a turbine, you've got magnets in there. Basically what's happening, do I need to review this? You've got magnets and a copper coil. If you take magnets and metal, particularly a highly conductive metal like copper, if you just put them near one another, they produce electricity.
Oh,
And so if you can get like a magnet to swirl around a copper coil like this, like a turbine.
we did that in elementary school.
That little guy over there is a wind turbine setup. So that little black piece, you put blades on it, that turns, so that's your turbine. Inside that bendy piece, it's got a generator, and the generator is plugged into the little amp meter, and it produces electricity. Not very much, but you can create electricity. That is fundamentally, that's a technology that we've had for about 200 years, is this copper coil magnet turbine generator situation. That is, in terms of the 21st century, kind of an antiquated way to produce electricity. That's why we need kids like you that are really bright to think of a different way to produce more electricity, particularly with renewable resources.
Nobody has come up with a different idea.
Well, people have come up with good stuff. You know, the hydrogen, using hydrogen as a fuel source. If we can get 100%, that'd be very difficult to do. But even a 90% efficient solar cell, that means that of all the photons that hit a solar cell, a solar panel, if it can take 90% of those and turn that into electricity, think of how much electricity we'd have. one of the issues with with renewable electricity sources is like with wind has to be blowing. With water has to be flowing. Okay, solar, sun has to be out. Geothermal, you have to have something that's active. The place has to be active. This, we can just put more stuff on the fire, in a sense, and burn it whenever we need it. Because the ultimate issue with energy is we don't really store it. We produce it as needed. If we could create a more efficient energy source and have an efficient way to store it, we wouldn't need these things. We could go to the moon, we could go to Mars, we could go to another solar system if we could just store the energy. But think about it this way, you know, a lot of times when we have a rechargeable battery, look how big that battery is. Okay, now think of the energy that it produces and the amount of energy that it's able to store. Think of what size of battery you would need for like a hydroelectric dam. We're talking about a battery that's the size of this building. That is not feasible. Also, what happens to renewable batteries over time?
They deteriorate.
Exactly, they become less effective. Now with the lithium-ion batteries, it's not as much of an issue. But lithium is a non-renewable, limited resource. We only have so much of it. And getting to it causes its own destruction, right? I think you guys have maybe heard like, electric cars are great, except they're ruining northern Canada. Because you have to mine the lithium, and it's very, very destructive to the surrounding habitats. So you can see, like, energy is a real issue, and I haven't even talked about climate change yet. Because what happens when I burn coal? What does it produce?
Greenhouse gases.
Greenhouse gases. Very good answer. Yeah, carbon dioxide, water, all that sort of stuff. Oil, when I burn it, what does it produce? Greenhouse gases. How about when I burn natural gas? Greenhouse gases. Yeah, exactly. Now, with uranium, it doesn't produce greenhouse gases, but now we have this irradiated stuff. What are we going to do with it? Right now, our answer is put it in the ground for how long? Some of that stuff is radioactive for thousands of years. So what we put into our nuclear reactors right now, our children, grandchildren, great-grandchildren, their great-grandchildren, and their great-grandchildren, and their great-grandchildren will have to guard this stuff so that nobody inadvertently gets into it and gets exposed to radiation, or terrorists don't grab it up and create bombs with it. Because you can make a dirty bomb. Just take a bunch of radiation, put it in a bomb, go fly over New York, you've got this sort of splatter effect of radioactive material. That's what a dirty bomb is. Okay? So this is stuff that we have to guard for thousands of years. That's not super feasible either. And this is under 24/7, 365 security.
I was gonna ask. I remember hearing about this in Mr. Bob's, but
Oh
wasn't
yeah, in
it
FPC?
Yeah, in FPC in South Africa, like some people tried to take over the something like that. Happened.
Yeah, they tried to take over a nuclear facility, and they were able to.
That's
What?
So we don't know where that stuff went.
Wait,
So
and America hasn't done anything about this yet?
well, there's not much we can do about it.
Usually we like putting our hands into everything that has to do with radiation.
Or anything.
That,
Really?
that's true.
Except
Anything.
Russia. Stay
Well-
away from that one. We're gonna freeze your
Oh,
assets.
I'm so disappointed with you guys saying this stuff.
Why?
I
What have we
also
talked
like-
about? What you are saying right now is such a horrible oversimplification of the issues.
Well,
Yeah.
yes.
Why are we not getting
Yeah.
into Russia? Oh my God! Don't
Because
get me
the Cold
started. That's
War.
a 3-hour conversation.
Oh no, I'm not
Well,
saying we
Why
should
did we
get
not
into
get
Russia.
into
I just
this?
think it's funny that we get involved in all kinds of other. I mean, it's not. I know it's not random, and I know that it isn't oversimplification. That word. I know that its ancient aspect is much more complicated than that.
Then don't say such
But
foolish
I
things.
do. Okay.
Don't say such foolish
Oh.
things. There's a lot of stuff that we get involved in on a humanitarian style, on a humanitarian basis that doesn't get as much play as all the stuff we end up getting in armed conflicts over. Okay? And how much money do we have? And what business is it of ours to get involved with some of these things? Is it in our best interest to get involved with stuff? You should know by now, hopefully from taking this class, that, you know, the big bad wolf that is portrayed to you of the American people, of the American country, of the American government is not what you think it is. It's so much more complicated than that. And you are not an encyclopedia of expertise on American or global issues yet. You guys are just skimming the surface of what is happening in this world and what has happened historically. So when I say, like, don't say such foolish things, I mean it. Wait till you've got the information before you start listening to teachers that shall go unnamed and their conspiracy theories.
Bishop?
Well, I hear there are other teachers out there.
Mr. Bly.
Yeah, I heard some of my teachers or some of my kids calling Obama an MFer, quote unquote.
Really?
And I'm just like, whoa. And I was like, why do you say that? And the things that they brought up, well, he did this and he did this, and I'm like, whoa, that is such an Are you watching Fox News? Like, where'd you get this information? That is so one-sided and inaccurate. And let's talk about all the good stuff he's done. I'm not saying he's great, but you're painting the man as being very one-sided. Remember, whether you're talking about Obama or America or any country in the world or any particular issue, get away from thinking black, white. It's all gray. There's so much information. And it's nice to be able to paint people as villains and heroes, but that's not the way it is. So, you guys should know that by now. Shame on you all. Anyway,
Hey,
getting
she's
back
the
to
one that brought
this.
it up.
Sorry. Rants.
Pointing.
But it needed to be said.
Oh, I
So
will.
anyway, something that you guys might want to do in your notes, since we've been talking about this, is start thinking about the pros and cons of these. So you might want to set up almost like a, here, I'll help you. You might want to set up almost like a list. Where's my tape? Ah, my freshmen keep messing with my tape.
I also like how when we were talking about the generator thing, the people watching this video aren't going to know anything that we're talking about.
What do you mean?
Because you're saying, it's like, so look over there and you see that thing and this thing, and so that thing connects to this.
Well, they gotta be here.
Well, yes, I know.
There's only so
It's
much
so
Mrs.
funny.
Jensen can do. Alright, here we
I think
go.
it's funny that they're gonna watch it and like be like, why are you talking about this right now?
At least we're not talking about what we talked about before we got going here.
Oh, I'm talking about that.
Okay, so
I
something
hope not.
So something you
That's
might want to do is, and you might want a new piece of paper or something like that. I would almost kind of set this on its side so it's landscape style. So here, maybe I can do that for those playing at home.
Who is this?
I'm not sure.
You got it.
So heavy. There we go. Don't mind any of this stuff. Okay. So you've almost got something set up like this. What you might want to think about is the pros and cons of each of these types of energy sources. So like in this column, you might have energy source. So this is where you would put oil, natural gas, nuclear, etc., etc. Pros. Because this could literally be a question on the AP exam, they'll say, you know, nuclear does this, natural gas does this. What are the pros and cons of each? List 2 pros and 2 cons for each of these energy source types. I mean, it could be like that. In fact, I think there's an AP question that was very similar to that a couple years ago. Let's see if I can't find it for you. Okay, so let's talk about oil, and we can maybe get some of these together. Oil, coal. How about we do them separate? Okay, so we'll do oil, coal, natural gas. Okay, and then we'll do uranium. And we'll kind of start with that. Okay, so what is a pro of oil? Or we can start with cons first. Cons are a little easier. Let's talk about the cons then. What is a con of oil?
Puts out greenhouse gases.
Yeah.
I think that's a con
Produces, I'm going to go GHGs, greenhouse gases. Produces greenhouse gases. What else? What is another con of oil? What do you guys know from just your lives? What is a problem with oil?
It's very
It's
destructive.
It pollutes, doesn't it?
Oh,
Pollute?
unrenewable too.
It's non-renewable and it pollutes. Non-renewable. Oil spills.
Yeah, that's what I was
That's
gonna say.
one.
Think of the Gulf.
ocean.
We
Oh,
will
right.
talk about Alaska and how the Exxon Valdez oil spill. We might talk about that tomorrow. I haven't decided yet. There are spills. And there are so many spills. There have been so many. Go search Wikipedia for, just go oil spills.
And that's
in
just so
Wikipedia.
sad.
And they'll give you like the top 10s and stuff. Like the Exxon Valdez was a huge spill. I don't even think it's number 5 or higher. I want to say it's like lower on the list. Most of the big oil spills have happened in like the like Gulf of Tonkin and the Mediterranean and stuff like that. Some of them have been out in the Indian Ocean and stuff like that. So like a little bit farther from land. But anyway, produces greenhouse gases, non-renewable spills. What is another thing that you think of when you think of oil? Think about politics.
It's
Where we get
what
the
we
oil
fight
from?
over.
Petroleum.
And where do we tend to get most of our, or where historically did we get a lot of our oil?
Middle East.
Yeah. So it's a hot topic, and it tends to be one of the problems with oil is not, at least before, it was historically mostly coming from the Middle East. Although it is in Texas. Texas is one of the places where it used to be naturally found. There's still a little bit there. It's really starting to run out. Alaska. Have you guys heard of Anwar?
Aren't they the company that wants to like?
No, it's a Anwar. Alaska. You'll need to know this for the test. Alaska National Wildlife Refuge. Anwar. This is in northern Alaska. You really have to go out of your way to go to this place, but this is where a lot of caribou are. There's a very distinct natural sort of wetland, tundra, permafrost style habitat. This is where you find a lot of Arctic foxes. It's a very special and unique habitat. It's also a place that has been largely untouched. That's one of the special things about Alaska, you know, the last wilderness, right? And it's one of the global last wildernesses, untouched for the most part. You know, if you ever go up there, you'll notice that there are parts that have been horribly molested. But there are some places like Anwar that have not been touched, that are relatively pristine. there aren't really roads there. There aren't really houses there. Now there are parts of Anwar where there's a local Inuit tribe. So Inuits is the political term for like Eskimos, right? They want to be called Inuits now. So there's still some native peoples that live there, and they hunt the caribou and stuff like that. Not necessarily in their historical ways. They've got big guns, but they aren't killing. They're not killing like hundreds of these things at a time, or at least they're not making a huge impact on their numbers. But the reason Anwar is a big hot topic with oil is because underneath Anwar are these pockets of oil. If we were to tap them, it's estimated that we'd maybe get a year's worth of oil at the rate we consume it right now. Some people have said anywhere between 1 and 3 years worth of oil. But then that begs the question, like, 1 to 3 years, and we're going into this untouched wilderness, you're really telling me that let's say 3 years worth of oil is worth absolutely destroying this wilderness and running the risk of like having a nasty oil spill. I mean, think of, they want to run a pipeline from it. And there's actually a pipeline that runs very close through here. You'll see pictures of the oil pipeline that goes from northern Alaska all the way down to Valdez. That's the Exxon Valdez spill. Valdez is a town, and it's a big oil export town. They take oil from there and take it all the way to Texas to be refined. Some places in California too, but the real oil refineries are in California and Texas. Why they don't do a refinery up there, I have no idea. Refineries are very expensive to make them. Anyway, Anwar, A-N-W-R. This will probably be somewhere in a question, somewhere on the test. It's a big deal. Anwar is a natural wildlife refuge and sitting on top of lots of oil. So produces greenhouse gases, it's non-renewable, it's associated with spills and habitat destruction. It was also an issue. It's not terribly abundant. In U.S. But they are starting to come out with technologies, like you maybe have heard tar sands and oil shale and all that sort of stuff. They're starting to, particularly like tar sands. Tar sands is basically a bunch of petroleum with sand in it. Now historically we couldn't really get the oil off the sand, but they now have chemicals and a process that can distinctly create, I don't want to say, they can separate the oil from the sand, and now we have more oil. So now the U.S. actually doesn't get very much of its oil from the Middle East anymore. It gets most of its. This is all information. This is so rich in information right now. This is everything that I've said to you so far is stuff that could be on an AP test. Most of our oil comes from the U.S. and South America at this point in time. Very little of our oil comes from the Middle East. And that's part of why our interest in the Middle East has really waned. You'll notice that the only reason that we're really over there is because of like terrorists and trying to shut down the Taliban and groups like them. If the Taliban wasn't there, we probably wouldn't be involved with the Middle East anymore. OPEC. Do you guys know what OPEC is? That might be something. Somebody look up the acronym. I can't remember. OPEC. OPEC. It's basically the conglomeration of Middle Eastern countries that had a monopoly for. Basically, they had a monopoly on oil.
OPEC, Organization of the Petroleum Exporting Countries.
Yes, and so that was mostly the Middle East. So this is what gave the Middle East a lot of power And if you look, can you tell me when OPEC was created? Or formed, founded?
Vienna, Australia, March 18th, 2014.
No.
No. Oh, wait, no, that's OFID. That's OFID.
It says September 10th through 14th, 1960 is when.
Wait,
what does the
was.
C stand
That
for?
sounds a little bit better.
Yeah.
OPEC
September
really came into
1960.
power
What does the C stand for?
as a force.
Oh,
Organization
Countries.
of the petroleum exporting countries.
Organization of Petroleum Exporting Countries. OPEC came about in the 60s, I want to say, and really became a force. They came together, if you've ever heard, like in the 1970s, there was a real oil crisis, a real oil shortage. Gasoline was rationed. That was OPEC. OPEC was like, US, So, OPEC will probably be on there somewhere. OPEC is becoming less and less powerful as the Middle East runs out of oil, and also as our ability to get tar sands to process oil tar sands. So oil, it's running out, but we do have, let's say, tar sands, and this is mostly in Canada. Tar sands make it a bit more abundant. It's going to last a little bit longer than we initially thought. A bit more abundant. Tar sands in Canada make it a bit more abundant, which means it's still relatively cheap. That's why gasoline is about $3.50 a gallon right now in the U.S. If it wasn't for the tar sands and being able to process those, I'm guessing gas would probably be about $4.50 to $5 a gallon right now. Yep, it's made that much of a difference. And obviously this is really controversial because it destroys habitats. All right. Coal, pro, is it's abundant in the US, which means it's cheap. Problem is, greenhouse gases, it's dirty, so when you burn coal, it creates a lot of pollution outside of greenhouse gases. It just creates a lot of the stuff that's in coal. You've got metals, you've got all sorts of different hydrocarbons that are not good for the respiratory system. So it's very, very dirty. One of the things you may have heard recently is there's supposed to be a coal railroad. It's supposed to be going through this area.
Oh, that's why they were making the protesting.
Yeah, and the thing is, like, we're not even going to be using that coal. That coal is being exported to China. But as it passes through here, even though it's not being burned, it's just on the backs of trains, it'd be open to the air, and as it goes through these neighborhoods and stuff, coal dust, comes off, and you get this sort of soot. And the soot in the air is not good for things that live around it, like think natural critters, and also think of us. Yeah. So we already have really nasty air pollution here in St. John's. This would just make it worse.
A lot of more people would have asthma.
Among other problems, yeah.
Like you could never wear white.
I don't know if it'd be that bad unless you lived right next to the train tracks and it was coming by. But it's one of those things that it's like over time. You'll notice, like, after 5-10 years of trains going through, you've got this much coal dust on top of your soil. So it's in the soil now, in the surrounding areas. And this stuff, like I said, is really dirty. It's got all sorts of carcinogens. Whether you burn it or not, it's just nasty stuff. You don't want to eat it. You don't want it in your soil. You don't want to breathe it. Yeah. So there's been a new campaign out right now, like, oh, clean coal, clean coal, clean coal. It's a cleaner way of burning coal, but these
so
emissions
dirty.
have to go somewhere. Do you guys remember maybe hearing on the East Coast about how there was a water contamination? People couldn't drink water for about 2-3 weeks. Did you guys hear about this?
think so.
Yeah, there's so much stuff. There's just never enough time in the day for me to tell you guys about all these things. Okay, for about 2 or 3 weeks earlier this year, God, where was it? West Virginia, I want to say. This little town. No, it was in Ohio. That's right. It was in the Ohio River. Parts of the Ohio River were contaminated because a chemical that they put on the coal to help clean it and stuff like that got into the water supply, and it'll kill you. It'll make you very, very sick. And over time, it kind of accumulates in your body. Very nasty stuff. Carcinogenic is all get out. Causes tumors and things. So, dirty, dirty, dirty. Coal all around is dirty. So there's sort of a movement now to go towards natural gas, which, guess what? Abundant in U.S., which makes it relatively cheap. Fracking.
What?
Have you guys ever heard of fracking?
Yeah.
No.
Okay, so this is where fracking comes in. I guarantee this will be on the test. Fracking. It stands for hydraulic fracturing. And I'll show you how this works tomorrow. Hydraulic fracturing. Basically, you've got, think of, here, let me get these. Hydraulic fracturing, that's what fracking means. Okay. This is a piece of shale. Now this type of shale is not the type of shale that they're using, but there are certain deposits of shale rock, and you can go ahead and feel this, and you can see the layers. Okay, it's a sedimentary rock. Shale is a sedimentary rock, and within those sediment layers are just little itty bitty bubbles of natural gas, methane, butane, propane, any sort of gas like that, carbon dioxide too. All these natural sort of gases that are produced in the process of making shale and stuff. And it's Burgess shale. You might hear that, Burgess shale. The Burgess shale refers to a layer of shale in the ground. This is about a mile and a half underneath the surface of the earth. And in these Burgess shale deposits, in between these layers are little itty bitty, millions and millions of little itty bitty bubbles of this natural gas. What they do is they drill down into the ground, mile and a half, and they create sort of a seismic wave, basically sort of like a mini earthquake. And they fracture the shale. That releases the little bubbles, and to get that gas to the surface, they pump a mixture of water and these chemicals down into the hole. And you guys know what happens if you have like a big long tube and you've got gas in it. You put a liquid in it and it'll deep displace the gas. Gas wants to rise. Water always wants to go to the bottom. So it displaces the gas to the surface, and then they pump out the gas. Problem is, with this hydraulic fracturing or fracking, is that it's hard to isolate this water chemical mixture, and so it can get into the water supply. If you guys look on YouTube, just put in fracking and get on YouTube, and you'll see people turning on their faucets and then lighting their faucets, and it's like whoosh, It's because it's natural gas and all this other stuff, all these other chemicals that are coming out of their faucet. Can't drink the water. That means people have to buy water. They have to bathe and stuff like that. Makes Nestle and those companies that own water, like Pepsi,
It's beneficial for them.
it's beneficial for them. It's beneficial for the natural gas company. Are they paying for your water though? No. You know, who has the money to bathe in Evian water or Dasani water or Nestle water?
Rich people.
Are the people in West Virginia and Ohio and Pennsylvania, are these all rich people?
No.
No. And a lot of people, here's the way it works, is a lot of people have this strange interest, because if there's a shale deposit underneath their homes, they actually get a little bit of that money. According to United States law, if you own everything below your house, if you have property, if you have a square mile of property, everything underneath that is yours. Whether it's coal, gold, water, whatever, that's yours. And so if somebody comes in and wants that resource, they have to pay you a portion of the money. And so people are like, yeah, I want money. Money sounds good. Not necessarily being 100% up to speed on what fracking is or the dangers of fracking, because when these companies come in, of course they're going to be like, yeah, these chemicals could get into the water supply, but I guarantee you, I won't put it in writing, but I guarantee you, you're going to be safe. We do this, this, and this, and you'll be fine. And it's like, no, it's actually really dangerous.
Does it destabilize?
That's another thing is it tends to destabilize, and people are getting these like earthquakes. I want to say it was over in Pennsylvania, not a super seismically active place. There are portions of the Northeast that have been feeling these little earthquakes, just little ones, thousands of them over the course of months and stuff, these little earthquakes. And it's not necessarily from them fracking. It'll be after they've left the area. And it's destabilized the water table, destabilized the sediments, and you see this sort of issue. So you've got a lot of problems with natural gas. It too creates greenhouse gases. When you burn it, it's not as dirty as coal. So people are trying to say like, okay, well if we're going to produce greenhouse gases, let's go with natural gas because it doesn't produce all these other things. It also doesn't produce as many greenhouse gases as coal. So even though coal is very cheap, relatively easy to get to, I think it's a little cheaper than natural gas. People are trying to go towards natural gas because it's relatively cheap and it's cleaner to burn. So if you live next to a place that burns natural gas, it's not going to be such a problem for you. And it produces fewer greenhouse gases. Still produces them, but fewer. So you can maybe put that in there, fewer than coal. And it's cleaner.
Did you mean to put the fracking in the pros section?
Yeah, that's what I was gonna
Yes. Cleaner. But it creates greenhouse gases. You've got fracking, which you might want to write down some of the issues there. Can upset the sediments, poison the water. Okay. Now, like I said, a lot of people are really in favor for this natural gas pipeline that they want to put in from like North Dakota down to the Gulf states. Have you guys heard of the natural gas pipeline? Yeah, a lot of people are very angry with the Obama administration because Obama is seen as more of like an eco-friendly president. But you have to think of like where he's coming from. A lot of people want this. It's cleaner than coal. It's relatively cheap. But if there were, say, a puncture in that gas line, unlike with oil, it's not just going to go on the ground. It's going to go into the air. And it'd be a lot of natural gas going into the air. So, you know, when you think of climate change, you don't need a huge plume of natural gas going off into the atmosphere. So there's an issue with that. It's a no-win situation for Obama because, or any president, I'm not trying to side with Obama, it'd be very difficult for any president because it's like, okay, well, we've got this whole problem with climate change. Obama gets climate change, but what do we do for the economic security of our country? Do we continue to import oil? What a pain in the butt. No, let's try and get something else. Coal, it's really dirty and it produces more greenhouse gases. This, relatively cheap, it's creating jobs in America, building the pipeline, getting the natural gases, all that sort of stuff. What do you do? So like I said, it's not black and white. There's a lot of shades of gray here. What do you do? I wouldn't want to be Obama. I wouldn't have to make
so
that
that's
that
why
decision.
people need to like look before they judge because they don't know how hard it is sometimes
Yeah.
to make those choices.
Do you want to decide whether we get a natural gas pipeline? Because that's thousands of jobs. That's a cheaper source of fuel, a better way than coal. It produces just as much electricity, but obviously people are getting these this water pollution, can't drink their water. They're getting sick from it. So we create these jobs, but then people get sick. Then we have the whole global climate change thing. If we burn all these fossil fuels, clearly that's a problem. Frick. How do you make that decision? It's a no-win situation. So think about that. Let's see. Uranium. Pros of uranium. No greenhouse gases. That's nice. Okay? And for that reason, this is not a fossil fuel. All of these, fossil fuels, because they're literally made from fossils. Not so much like dinosaur fossils, which is what a lot of my kids think. They're like, I'm putting dinosaurs into my gas tank. Actually, you're putting like sediment from the ocean that happened like millions of years ago. You're taking that, refining it, and then putting it into your gas tank. It's less about dinosaurs and more about diatoms.
Can we just call it dinosaur
It's
fossil?
more fun to think about,
Yeah.
right? Like, there goes the Stegosaurus.
Just melt that sucker down and put them in my tank. So these are fossil fuels. Okay. Uranium, no greenhouse gases. Yay, it just creates steam. That's it. Nothing wrong with steam, although it is a type of greenhouse gas, but it's not such an issue. And if you think of like,
Steam,
well,
just water.
how is water a greenhouse gas? Well, think of how warm it makes your bathroom. It's really good at trapping heat. Actually, it's really effective at trapping heat. Methane, we'll talk about this in a bit. Methane is actually a more potent greenhouse gas than, say, carbon dioxide. So if I take this natural gas and just let it off into the atmosphere, it's mostly methane. That would be more destructive than burning it. So if you guys ever see a coal, like for instance in North Dakota, they're mining for coal, right? And they're also getting natural gas, but they are producing so much coal and so much natural gas is coming up, they can't catch it all. They don't have the facilities to tap all this natural gas. So they're actually just burning it. And people like come up and they're like, "Oh my God, look at that!" They've got like literally pipes, and out of the end of these pipes, these flames are just shooting, right? And you're just like, "Oh my God, how can they burn that? Those jerks!" You know? But it's like if they don't burn it, it goes into the atmosphere, and it's a more potent, what we call a more potent greenhouse gas. So it's better to at least make it into carbon dioxide, I guess. Also, if it doesn't get out of the coal mine and there's any sort of spark, highly flammable, dangerous to the miners. So something to think about when it comes to coal. I know this is so much information, right? Okay, uranium, no greenhouse gases, but then what do we have to deal with for the next 1,000 years?
Radiation.
Radioactive,
Guarding it?
yeah, radioactive waste. Radioactive waste that lasts thousands of years. Some of it doesn't last that long, but some of it does. And it has to be guarded 24/7, 365. It needs to be guarded. Because like I said, you could just take a whole bunch of stuff, shove it in a bag, go dump it in the streets of Manhattan, and you've got a real problem. Yeah. Or take all that stuff, put it in the local water supply. That's all you've got to do. It's like the dummy's terrorist. You can be a stupid terrorist and really cause some problems just with radioactivity. So that's why it has to be guarded 24/7, 365. Okay? No greenhouse gases. One of the problems with nuclear power is that it's initially very expensive to create a nuclear facility. It's a big upfront cost. So, big upfront cost. And we're talking billions of dollars. It costs billions of dollars, millions most of the time billions of dollars to create a nuclear facility. Big upfront cost. Do you think the local guy who pumps gas can run one of these things?
No.
No. So you have to have a highly trained workforce on call 24/7, 365. Otherwise, what happens? Chernobyl, Fukushima. Now,
Just go.
meltdowns are very, very rare. More people have died in plane crashes by far than people have died from these nuclear meltdowns.
But the meltdowns have like long-term effects.
Exactly.
which
Are
is
you
the
going to
flip
go
side.
summer in Fukushima anytime soon?
No.
Are the people who initially lived there going to move back?
Oh no.
No. People who lived near Chernobyl haven't even come back, and that happened right around when I was born. So we're talking ages ago, dog. But meltdowns are very, very rare, but lasting effects. And something we don't have a whole lot of time to talk about is the psychological effect of a nuclear meltdown. This is something that won't be on the test, but let's talk about Chernobyl and also Hiroshima and Nagasaki. One of the things about radiation is you can't see it, you can't smell it, you can't feel it. So on a psychological level, it's terrifying. Are you safe? Are you not safe? Can you have babies? Can you not have babies? If you do have babies, are they going to have like 3 arms? Are you going to die of cancer? When? When is that going to happen? Very few people, let's talk about Chernobyl. Very few people died, actually. Outside of that first day when there was the meltdown, most of the people that died worked in Chernobyl, in the reactor. Most of those people died. Officially, there's only about 200, 300 deaths from Chernobyl. Now, there was fallout. When it blew up, it sent a lot of that into the upper atmosphere. Here comes the wind. You know, a lot of people in Ukraine and Russia, even in parts of China, Turkmenistan, Kazakhstan, Afghanistan, they got little fallout from it, right? But, you know, how do we measure those effects? It's very difficult to say, you know, this person got cancer prematurely because of Chernobyl. It's really hard to say that. So the official toll, like death toll for Chernobyl was like 200, 300 people. But the bigger one has been estimated to be upwards of like 14,000 people. But included in that number are people who died because they lost hope. They thought they were goners. This terror of radiation. So what you saw in Ukraine, because that's where Chernobyl is, what you saw is that people, particularly young people about my age, your age, just became reckless nomads. They were drinking too much. There was a lot of unprotected sex, promiscuity. People were just, had this very devil-may-care attitude and treated their lives very, recklessly. As those people died, that helped the death toll. Because even though the radiation didn't kill them, their terror, their psychological terror, and how they dealt with it changed. But look at Hiroshima and Nagasaki. We dropped nuclear bombs on those people. Those people saw the same types of radiation. Why aren't Japanese people being born every day with like 3 heads? Actually, radiation is one of the most misunderstood and terrifying things out there. People are absolutely terrified by nuclear radiation, but actually there's different types of nuclear radiation. If you ever took my FPC class, we talk about that. You've got alpha, beta, and gamma radiation. Alpha and beta can't even go through your skin. So unless you directly digest them, like in your food, unless you eat food that's contaminated with alpha or beta radiation, it can't even get through a piece of paper.
I didn't know there was different types of radiation.
Exactly. This is why me and Custodian Joe get into fights. Is because he's like, oh, there's a plume of radiation coming this way. And he sends me these conspiracy theory articles and stuff like that. Not all radiation is bad, and if you're worried about radiation, don't eat something that you think is contaminated with it. Like Fukushima. There is a lot of stuff coming out that look at the tuna that grew up around Fukushima, don't eat the tuna. Okay, well, I'm just going to have to not eat sushi. That's how I eat my tuna. I better be really careful about where my sushi came from before I eat it. Because there's radiation in it, allegedly. Now, what am I going to do? Get my Geiger counter out at the table? No. So, you got to be really careful about that. Obviously, that's going to affect Japanese people more than you and me because they eat a diet that's primarily marine in nature. So that is a real problem for them. Fukushima will probably be bigger than the Chernobyl disaster, even though it was a smaller explosion. Because it was right next to the ocean. If any of that leaks into the ocean, people are going to eat that stuff. Now, like I said, alpha and beta can't even get through your skin. But if you eat it, it's the most dangerous. It's the most disruptive. Gamma can go through your skin. It's not as disruptive. And as I sit here right now, with most of these shades drawn in this room, gamma radiation is going through the ceiling, through me, all day long.
Oh, because of the sun?
Yeah.
Radiation of the sun.
Yeah. You guys are worried about radiation, right? Oh, frick, I
But
don't
it's
want to
like
get that. Go stand out in the sun for an hour. It's more dangerous.
Is that why there's cancer, like skin cancer, because of the radiation of the sun?
Exactly, gamma radiation. So it's all about the dosage.
But it's less, right, because of the ozone layer or something?
And that is the purpose of the ozone layer. The ozone layer blocks a lot of radiation. Without the ozone layer, more of that gamma radiation can get through. You get alpha, beta, and gamma, but more of that radiation comes through. And that's why the ozone hole, which is over Australia, it's kind of right over in Australia. People in Australia have to take skin cancer very seriously. So when they go to the doctor, they get mole maps. I learned that when I moved down to New Zealand. Yeah, when they go to the doctor, part of their exam is taking pictures of their body and taking pictures of all their moles. And over the years, they compare the sizes.
Wow.
Yeah. And that's because they live under the ozone hole. But the ozone hole is starting to shrink back up because of regulations that have helped decrease these chemicals that cause problems.
How can you tell where the ozone hole is?
The same way that we can detect water on planets that are millions and billions of miles away.
Okay.
Because chemicals have a signature. And if you've got the right sort of eyes, a detector, if you have the right sort of equipment, you can see ozone. You can detect it. Because each chemical has its own, you guys will learn this if you take chemistry, it has its own little wavelength. So right now, my ASAP club, we have these little tubes, and we're looking for NO2. What we do is we expose NO2 to this certain chemical. It's called, its abbreviation is NEDA, N-E-D-A, and it gives off a certain wavelength of light at 540 nanometers. Okay, that's NEDA. You don't need to write that down. Anyway, it has a wavelength, so its bonds vibrate at a wavelength of 540 nanometers. So to my eye, it's purple. But I can only detect what's in the visible spectrum. Ozone, as I look out the window, I don't know what ozone looks like. It's not blue. I don't know what it looks like. I can't detect it with my eyes. But if I have a certain type of eye, a certain type of detector that can see beyond the visible spectrum, beyond yellow, green, red, blue, all that sort of stuff, UV, microwave radiation, gamma radiation, X-ray, those are all types of radiation. And so is light as it comes through this window.
What is UV?
UV, ultraviolet.
No, but like I heard of another one, UV.
Mhm.
There's no other one.
There's UVA, UVB, and UVC.
Oh, it's probably UVB.
Yeah, so when you guys go to the store and you get sunblock, a lot of what the ozone, so the ozone blocks a lot of radiation, particularly UVA and B, but you get a lot of C, okay, along with like gamma radiation and all that sort of stuff. When you use a tanning bed, you get a lot of A, B, and C. That's why using a tanning bed is more dangerous than sitting out in the sun, is because you get A, B, and C, and UVA and UVB is more powerful than UVC. Different wavelength, that's all it is. Different wavelength. So, anyway. So, pros, no greenhouse gases. Meltdowns are very, very rare. But you have to deal with radioactive waste. If I have a rod of uranium, it doesn't last forever. So what do we do with that radioactive waste? Have you guys heard of, God, where is it? It's right across the river. My friend Polly worked there. God, why can't I think of it? Oh, if you look it up, look up nuclear power plant, Washington. And you'll see Trojan, the Trojan power plant that was just north of here. Are you guys old enough to remember the Trojan nuclear power plant?
Heard of it, but
I have no idea.
No. Y'all are so young. There used to be a nuclear
I
power
moved here though. I'm from Eastern Washington, so.
If you guys were my age, you would have seen the Trojan nuclear power plant. It's like, do you guys know where St. Helens is?
No.
It was like basically between St. Helens and I-5. Like it was up that way. So it was technically kind of in between Washington and Oregon on the river there. But
So it wasn't as far.
it wasn't super far. But one thing to remember about these is particularly these power plants that are shaped like this, like on The Simpsons, those ones are designed for a Boeing 777 to crash into the side of them and not crumble. These are very sturdy structures. Anyway, there's a nuclear power plant that used to be on the other side of the border, farther up the Columbia. I cannot remember its name right now. It escapes me. But anyway, they're struggling because when it was built, we were still kind of trying to figure out how to store the nuclear waste. You know, can we dig a hole, pour concrete into the hole, and then put this stuff in barrels into that concrete hole and then cover up the hole? Is that okay? And what we found out is no. You got to dig a really deep hole and really put it in some heavy duty barrels and then cover it up with more cement and have like half a mile of dirt on top of that. That's what there's, oh God, why can't I think of the name? There's another place in New Mexico that its whole function is basically a great big hill, like a big ridge of hills, and they dug underneath it so that you have that extra bit of space. They dug into it, and it's a nuclear depository. That's where all the nuclear waste in the U.S. goes. It's a nuclear waste depot. Heavily guarded by some of the most highly trained individuals in,
How do
in
you
the nation.
get like trained to be?
It's just part of the military. There's a part of the military force. So the military protects it. It's a military installation. I have a
crazy security guard.
Yeah, my grandma actually was driving around with one of her friends just on a day out. They had their picnic basket, and they were just going for a drive through New Mexico. And all of a sudden, they started seeing like, chain link fence. And my grandma, being stupid and also curious, drove into this place, and these guys with like AK-47s like roll up on her.
They were ready to shoot
Well,
her.
they had SUVs and stuff, and so they, pull up on either side, and they're like, "You need to pull over, ma'am." And they checked all of her information. Everybody who was in the car, they checked their information. This is a little old lady, right?
Right.
But I mean, you can't trust anybody. Maybe it's the Trojan horse of old ladies. Maybe there's some wacko in the trunk, right? So anyway, they check everybody. They check the car. Everybody has to get out. They check all their things. They check everything. And they're like, ma'am, you are within so many miles of this nuclear base depository. Under federal law, you must leave or you will be sent to prison. And she's just like, well, I'm just going for a ride. So she turned around and got out of there. But yeah. You can't come within a certain distance. Your taxpayer money pays for that.
Oh, that's nice.
Yeah,
I hate the
yeah.
taxpayer
That's
money.
my reaction. So when people are like, "Ugh, taxes," and I'm like, it's not all bad.
Right.
Gets wackos away from the nuclear waste. But that,
Like your grandma.
Huh?
Like your grandma.
Yeah, crazy people like my grandma gets her hand on some nuclear waste. No telling what she'll do with it.
Drive a picnic, some bombing again.
Yeah. So no greenhouse gases. Meltdowns are very, very rare, but when meltdowns happen, they have very lasting effects, both real and not. Like I said, both medical and like psychological. There's radioactive waste, big upfront cost. One thing that's also nice about all of these is that they can create. This is one we'll put for all of them. Create energy on demand. So that means no matter what time of day it is, no matter what day of the year it is, you can just put more oil, put more coal, put more natural gas, put more uranium in, and you'll get more electricity. Can you do that with wind, solar, or hydroelectric? Not so much. With hydroelectric, it's a little bit easier. But yeah, you've got a problem. Because that stuff, is it available all year round, 24/7, 365? No. If it's not a windy day, it is just not a windy day. If it's not a sunny day, it is just not a sunny day. If it's, the summertime and the rivers are relatively low, hydroelectric dam is not going to pump out so much water or so much electricity. Okay, so these are fossil fuels and uranium. So this is your pros and cons for non-renewable resources. Let's do one for renewable resources. The big con for those, for the most part, is they cannot create energy on demand.
That's interesting.
So let's continue our 3 columns, pros, cons. Let's talk about hydroelectric. Okay, I will do dams, and then I'll do waves. I'll probably put way too much space in here. Hydroelectric, dams, waves. Then we'll do biomass, and solar, and geothermal. Everybody at home? Still getting this? Okay. Alright. So obviously a pro for all of these except for biomass is that they don't produce greenhouse gases. Meh. Meh. No greenhouse gases, except for biomass. And then we burn the biomass that produces carbon dioxide, but it's basically burning trash and trashy-like stuff. Trashy stuff. That means if I have, for instance, if I'm a sawmill and I've got tons of bark, what am I going to do with all that bark? Well, I can make bark mulch. What do I do with like all the sawdust? Okay, well I can make that as sawdust. What about the other little bits and pieces? Odd ends and bits. You can sell that to biomass burners. So, for instance, there used to be an old coal fire facility in eastern Oregon. We used to burn coal in Oregon. We don't do it anymore. That is now a biomass facility. Yeah. So if we need to, this helps create a lot of energy for our eastern Oregon neighbors. Because like here in Portland, we get all that energy from the hydroelectric dams, like the Bonneville Dam and stuff like that. It's hard to get all that energy efficiently over to, say, La Grande. Or somebody in the far, far, far southeast corner of Oregon. What are they supposed to do? So for them, it's a better source of energy to be able to burn biomass. They can also use solar and geothermal over there. But over here, we can use hydroelectric dams. Okay, so let's focus on hydroelectric dams. No greenhouse gases, but they do cause a lot of destruction to habitats when you build them. Also, they disrupt salmon and migratory fish runs. So you have to have like some sort of fish ladder for the critters to get up. So destructive to habitats. But that's local habitats as opposed to global habitats with the global climate change. Destructive to habitats, salmon runs, places called riparian areas. Do you guys know what a riparian area is? A riparian area is the space between, like, say, the edge of the river and the forest. It's almost sort of like a wetland. So it's a distinct type of ecosystem. We haven't talked very much about it. But riparian areas, this is where most of our amphibians and reptiles and things like that live. Particularly amphibians. So destructive to habitats, salmon runs, riparian areas. For the most part, you get, in most places, you get year-round electricity. Unless you have a river that really, really has low flow. So one thing that we're afraid of with global climate change is as Washington and Oregon get warmer and we get less and less snowpacks in our mountains, there'll be less water to feed the Columbia. Less water feeding the Columbia means less electricity. Does that make sense?
Yeah.
It's a complicated topic. There's just so much stuff, right? Year-round electricity with wave energy. Basically, there's a lot of different types of wave energy. It's still in the developmental phase. Europe has taken the lead with wave energy. But if you guys are interested in developing this, Oregon State has a lovely program on wave energy.
Advertising for Oregon State.
Well, honestly though, Oregon is a really good candidate for wave energy too. So like I said, they were going to build one off the coast of Reedsport. Now they're really more focused with, where did I forget wind? Wind, we'll do another one for wind. Anyway. Wave energy also, now unlike hydroelectric, you get sort of year-round electricity because do the waves ever stop? Waves never stop. So get year-round electricity. Biomass, you can get year-round electricity 24/7, all day long. Solar, obviously you can only collect it during the day, so only available during daylight. So geothermal we can do year-round as well. So solar is the only one that doesn't do it. Let's see, what else with hydroelectric dams? There's upkeep. They're not super expensive to upkeep, but you do have to upkeep them. With wind energy, that's a big problem. Wind energy. Wave energy, huge upkeep costs. Why would wave energy be really expensive? Think about the nature of the ocean.
Because you still have to go out and get it, or whatever.
Wouldn't the waves just degrade whatever it is that is involved?
How? There's two different ways that waves can degrade it.
Rust.
Rust. Yes. Are these things going to be made out of plastic?
No.
Even if they were made out of plastic, the salt would screw them up still. Yeah, so these things tend to be metal in nature. How do you make metal rust-proof? It's not as easy as just being like, well, make everything out of stainless steel. Stainless steel is only stainless to a point.
Yeah.
Yeah. This is made out of stainless steel. I put that outside for a week. Oh, it's not going to rust. I put it out there for a couple of years. Poor table, poor chair isn't going to last that long. Okay, so huge upkeep from rust. What else? What else happens in the ocean? You guys clearly haven't lived on the coast.
Sharks eat stuff. No? Okay.
I don't think sharks are gonna be out there, or out
In
on
the
that
ocean?
coast.
Yeah, obviously.
Out,
Think
not
about
out,
waves.
not out in Oregon coast.
Think about waves.
Tsunamis.
Well, even regular waves. Waves are huge and they're very, very powerful.
Oh,
You
yeah,
got a
like,
big wave. It could
When
really
I went to the beach,
twist and mess up your stuff.
like they were going up to like more than a foot long, like high. We were up on the rocks, and then like they still touched our feet when we were there.
Yeah. So waves can be really high. They can be really crazy. So you can get twisted up bits and pieces from that. So the waves are inherently destructive. Plus you've got rust. That's my oven. Hold on a second.
Just started out quiet.
Oh, I thought you were going to answer, and I was like, I was just thinking everybody at home is gonna want to have that conversation.
Like, yes, honey.
He's
Wait,
just getting in from Boise, I'm guessing.
I
Yeah, they had a rugby game,
Oh,
which they lost.
oh.
But Boise's a really good men's team. The women's team actually beat my team this year once. We really handed it to them when we were there. So we win overall. But anyway, huge upkeep costs. Remember that. Just think wave energy, waves, ocean, salt, rust, crazy storms. So this is a very, very, very expensive endeavor. They spent $14 million on the facility outside of Reedsport. Still don't have it built.
Oh my god.
Yeah.
That's crazy.
So if we could harness the power of waves, and there are so many ways that we can do that. I mean, there's the piston idea where it goes up and down with the waves, and so it basically pushes down this piston. The piston drives down air or water, and it turns a turbine, which turns a generator and produces electricity. There's one where the waves flow through, like almost like a tube, and there's like a turbine inside the tube. There's that idea. There's one where it's more tidal, so as the wind or as the waves come in and displace this stuff, as they go in and then as the waves go out, it turns a turbine. Problem is with this also is that you have potentially loss of life from critters, because critters get sucked up into it. So it can kill critters. Or people are worried that it might change the migratory routes. Also, as they, like for instance, if they make that piston one, you gotta like drill that into the ocean bed so it stays in one place. That can be destructive.
Yeah.
So, wave energy, super, super abundant. Super abundant. Do waves cost anything? No. It's a free, in a sense, source of energy if you can harness it. But the device you use to harness it, very expensive, needs lots of upkeep, a lot of moving parts, a lot of maintenance. So that's an issue. Is wave energy more expensive than, say, petroleum and all that sort of stuff? No. So it's a matter of like people are afraid in this economy. People are very critical of like government investment and stuff, you know, and so it's like we know that we need a better, more abundant source of cheap energy, but it costs money to put in this infrastructure. Whether you're doing a nuclear power plant, you're putting a hydroelectric dam, you're putting in a wave buoy, you're putting in solar panels, any of that, those are government costs. Usually the government puts this stuff in. That has become, over the years, less and less popular. So PGE, along with other big energy companies, have come in and said, okay, we are a private organization. We'll build it. We'll manage it.
Why
will.
are they skeptical about the government putting in money into something so that way there's more energy? Wouldn't they just think
And that it's regulated, right? Because if a company, exactly, like if a company like PGE comes in, what's stopping them from charging whatever they want? Because they have a monopoly on that source of energy, right?
Oh, yeah.
Nobody else owns the Bonneville Dam, right? It's PGE. They can charge whatever they want if they wanted to. There has to be government regulation in there so that they don't. But a lot of that cost
there
that the government would
regulation
normally
there?
shoulder, if the government, let me put it this way, if the government built a hydroelectric dam, it would own it, it would maintain it, it would, you know, put the men and women in there to keep it running, and it would be relatively cheap because it's the taxpayers. Now, the con, like the alternative situation is a company like PGE can come in, create this thing, They own it, they maintain it, they can charge whatever they want. But the taxpayer didn't put that money in on that upfront cost. Which one is better? You kind of have to look at the long term. In the long term, it's better that the government maybe buys it. But when we start looking at like, okay, well, it's going to cost $20 million or $1 billion to build this dam, that's money in the budget, discretionary budget, for us to build that. And right now, in this climate of like, cut the budget, cut the budget, cut the budget, cut the budget, people don't want to do that. So there are, you know, there are consequences to us being cautious, and understandably so, being cautious about where we spend our money as taxpayers. We don't want the government going crazy with it, but there are benefits to having the government's, you know, maintain. Can you imagine roads? On the East Coast, there are places where the government didn't build that bridge. And guess what you gotta do? You gotta pay a toll. Yeah. So there are pros and cons to having the government have that infrastructure and having it be the people's structure versus a private structure. You just gotta kind of weigh those pros and cons. So there is huge upkeep. All of these, every single one of these takes, you know, input. Biomass. Let's talk about biomass. Like I said, just imagine corn husks. Now there's two types of biomass. You can either burn it directly and treat it almost like coal or natural gas. Or what you can do is basically have a decomposition chamber where microbes get at it. And as the microbes eat it, they produce methane. Tap that methane, now you can burn the methane like you'd normally burn natural gas. So there's two ways that you can do it. Either way, you're burning stuff, and it's going to turn a turbine, which turns a generator. This is great for getting rid of trash. Gets rid of biomass, you know, trash. Now they can't break down everything. You can't just throw a, you know, trash bag full of randomness into this stew of microbes. But you can throw it into an incinerator. Now, that is one thing that people have done. But that's one thing that, you know, a landfill takes up space, right? Space is at a premium. People don't want to live next to a landfill. So a lot of times, like if you drive south of here on your way to Salem, you guys will notice there's a big hill, man-made hill. It's on the west side of the I-5. You'll notice it. And when they're putting stuff in, it's gray. Almost like ash. It's because it is ash. They incinerated the trash. And instead of having a great big mountain of trash, you now have a smaller mountain of ash.
Oh, trash.
Trash ash. You have trash ash. So there's a lot of benefits. Instead of that trash sitting, taking up way huge amounts of space and smelling horrible, leaching, that is a technical term, leaching into the groundwater. So think about it, you've got all that wetness and coldness and all this stuff, all these chemicals being dripped into the, you know, into the bottom of this landfill pit. It's called leachate. And it goes through a process of leaching. Literally, it gets sucked, like a leech, think of that way, into the ground. Now that can mix with groundwater, and then it's yucky. You don't want to drink that. Also, it leaches into the soil. And are you going to be able to put a farm on top of an old landfill? No, you don't want to do that. It's got all these nasty chemicals. So burning biomass, particularly burning trash, gets rid of this giant pile of stinky, wet, messy yuckiness, but gives off greenhouse gases. So does a landfill. As that stuff sits there and biodegrades, it also gives off greenhouse gases. This obviously gives off more.
Probably more just at once, whereas the landfill just gives off
a smaller amount, but constantly over time.
Yeah, over time and over a long period of time. So either way, you're going to get a lot of greenhouse gases. It's just right now or over the next 10 years, 20 years. It is an interesting way to get rid of trash. I don't know how I feel about it. There's a lot of pros and cons. Thinking about global climate change, every little thing adds up. So, do we pollute the local area? You know, that stuff gets into the ground and all that sort of stuff, sits there, stinks, drives down property values. Do we pollute the local area or do we pollute the global area? So when it comes down to that, it's, in my personal opinion, I would rather
Pollute the local area instead
pollute
of
the
the
local
global.
area. And when it comes down to like hybrid cars and they're mining for the lithium up in Canada, it's like, oh my God, you've got all this beautiful landscape that's just dying.
Destroyed.
It's just being destroyed. But then you have to go back to global climate change, and it's just like, well, if that means that I use less gasoline and burn less gasoline,
How about you walk more? You bike more.
I'm not a walker.
Bike
Hydroelectric, hybrid car is about as good as you're gonna get with me. I am
more. You
committed
have a
to the
hybrid.
environment. Yeah, I've got a Prius out there.
Oh, you do? That's awesome.
You would imagine a
So
scientist
anyway,
if you're having-
biomass gets rid of trash, gets rid of a lot of agricultural waste, like I said, like think corn stalks and things like that. This is a great way to get rid of livestock sewage. Turn the bacteria on that. Break down that bacteria so that we don't have that sewage going into our rivers and stuff. It's an option. I mean, biomass is sort of a new thing, and it's kind of, it's not a good solution, but it's not a bad solution either. Okay, solar, no greenhouse gases, cheap, abundant source of energy at least during the day, but right now the solar panels are not terribly efficient. They're expensive. And unless you have some sort of government subsidy, people are not going to buy them because they're too expensive. And they are expensive. Now, I have a house that has all south-facing windows, south-facing roofs, and there's no trees between me and the sun. I'm actually thinking about putting solar panels on my house. And I get a tax break for doing it, and I get a subsidy from the government that helps drive down the initial cost of buying them. One thing that's really nice about solar is I can power my house, and if I have any excess power left over, I can sell it back to the grid. So like PGE would buy it from me. Yeah,
So
that's
you can
one
make
thing
a
that's really
profit.
nice.
So you
So
can
I
get
could make
money
profit.
from it?
Yeah.
Smart.
Yeah.
Tax
So
breaks
there-
and a profit.
Yeah, so there's a benefit, like a cost benefit for the individual person. Now, when it comes to solar, there's a lot of different types of solar. We'll get into it tomorrow, but there's lots of different types of solar. Obviously, me having it on my house is going to be helpful, but what do we do for people who can't put it on their houses for one reason or another? They can't afford it, they're surrounded by trees, et cetera, et cetera, et cetera. There are things called solar farms. You'll see these out in the deserts and stuff, these open areas. And what they look like is a bunch of mirrors. A lot of them, what they're doing is they're focusing that heat, almost like a satellite dish. They focus it into one location. Have you ever played Fallout New Vegas?
Not New Vegas, but
Okay. In Fallout New Vegas,
been trying to find it.
yeah, in Fallout New Vegas, one of your first missions is you have to give power back to the valley, and the way that they do that is, and it's in Nevada, so
Oh.
desert. So you're out in the middle of the desert, and there's a solar farm. So you've got to align the dishes so that they focus on this one place and produce electricity, and then everybody loves you because you created
Until
all
you
this
blow up
electricity.
the town.
Is this a video game?
Yeah.
Yeah, that's what I thought.
Play New Vegas. It's a great game. One of the best games I've ever played. Anyway, solar. Only available so you only get power during the day, although they are getting better with being able to store some of that energy, like for your house, for like New Vegas style solar farm. It's harder to store that.
Because there's so much.
Like I said, think of a rechargeable battery.
Oh, right.
The size of the battery needed to hold that
Would have to
would be
like
ridiculous. And then you want to talk about northern Canada
Can't they just-
crying because of these batteries being built.
Can't we just have like make a lot more like smaller batteries and hook them up so that when one battery is charged, the charge just goes to the next one?
Oh, what's the difference between a big one and a bunch of little ones?
Well, nothing. But
Yeah.
I'm saying
It's
appeal
fundamentally
to.
the same issue as what I'm saying is that we don't have batteries. If we could make more efficient batteries, that's why I'm excited about the lithium ion battery, because it is more efficient. The rechargeable batteries that I have in my house are like nickel cadmium. The one in my hybrid car is a lithium ion. Now those are more expensive, but they're more efficient. I'll have that battery for the next 15 years on my car, which is longer than the normal batteries that you put in a car. Normally with the battery in your car, you gotta replace it every 4 or 5 years with like regular use. So it's a more efficient battery and it's rechargeable. Much better than nickel cadmium. Both are bad for the environment once they break down. But anyway, solar. Yeah, so there you can see solar. Solar is kind of like all the rest of the renewables. A lot of pros and cons. Really, the big issue is the upkeep cost or the initial cost. That is what I want you guys to remember about renewables. Big upfront cost, long-term benefit though. With fossil fuels and nuclear, well, with fossil fuels we'll say, with fossil fuels, right now our system is built around them. So the infrastructure is already there. We don't have to build a new refinery or anything like that for the most part. Although with these pipelines that we're building in, there is an upfront cost. The biggest issue with these fossil fuels is cheaper to put into place global climate change. These, it's the opposite. And then how do you get the taxpayer to approve it? It's, and then people are very short-sighted about it, like what's going to hit my checkbook right now?
Mhm.
And when you look at it like that, that's why we've stuck to fossil fuels. When kids come in to my classroom all the time, they're like, did you hear about that guy who took that oil from McDonald's and he ran a car off of it? It's like, yeah. Did you hear about that guy, that one company that has hydrogen fuel cell cars? Yeah. Did you hear about the electric cars you can just plug them? Yeah. We could go to that right now. And it's not like the government is shutting that stuff down. It's not that they're shutting it down. It's just that the people are not ready to to change their lifestyle. I gotta go home and plug in a car. I gotta make sure when I get to work that there's a plug-in station there. Ugh, whatever. I gotta find a hydrogen fueling facility. There aren't any of those in Oregon. It's an infrastructure issue. And infrastructure issues come with upfront cost issues, and the taxpayer does not want to hear it in this economy. So that's where, a lot of times the government has to come in and say, this is what's good for the people, whether you guys like it or not. This is going to cost some money, but this is better for the whole world, and it's going to be cheaper for you guys in the long run overall. Look at hydrogen. We're not going to run out of that anytime soon. It's the most abundant element in the universe. 97% of what's out there is hydrogen. I want to say, yeah, 70 or I get confused. Anyway, geothermal, last one. Ooh, we're past 4:30. Sorry, guys. Geothermal, really, it's just maintenance, upkeep costs. The real upkeep cost with geothermal is obviously you're building a power plant on top of a geothermically active site. So the ground is more apt to shift. You're gonna get big spikes in temperature sometimes. Sometimes it's more active during this part of the day or this part of the year. You get these sort of spikes of power. So it's inconsistent. Inconsistent upkeep costs are they're, I wouldn't say they're outrageous. It's not like wave power. It's not outrageous. Another con is it's only available in certain parts of the country. So it's regional. So for instance, geothermal isn't a good option for people who live on the coast of Oregon. Better for the people who live in southeast Oregon and in Idaho and in Colorado. So it's regional. There are some upkeep costs. Obviously, you got to build the thing, so there's infrastructure costs too. Inconsistent with its power output, but no greenhouse gas. Well, as it vents, it creates greenhouse gases, but it was going to do that anyway. So not really a big issue with greenhouse gases. Cheap. Once you get it going, it's relatively cheap. Same thing with solar. Once you get it going, relatively cheap. Waves, dams, relatively cheap for this one. Not so much for waves. Yeah. And then with wind is kind of like waves. There's a fair amount of upkeep cost. There's fear that it'll kill critters, but house cats kill more birds than these wind turbines. So don't let people tell you like, oh, these birds are just flying into them. It's like a magnet. No, birds. Very few birds are killed by wind turbines. One of the problems with wind is it does have noise. It can be put, one thing that's a pro is it can be put out in the ocean, it can be put in the valley, and it can be put on hillsides.
Wind turbine?
Mm-hmm.
So they have like a diverse.
Yeah,
area.
it can be kind of put wherever there's wind. The most efficient place, you might want to put this into your notes, the most efficient of the three is out in the ocean, produces more wind power. The second most efficient place is hillsides. So if you can, you either want to put it on a hillside or out in the ocean if you want lots and lots of energy. Ocean, by far the most energy. But, as with wave power, what's an issue with ocean wind turbines? Rust. So there's a real upkeep issue there. But, nobody has to look at them. So it's not a eyesore for people. If they produce noise, nobody cares because it's out in the middle of the ocean. Wind farms are a big thing over in Europe, particularly ocean wind farms. They're all over the North Atlantic right now. Like I said, big infrastructure cost, upfront cost. No matter where you put them, it's going to be a big input cost. Hold on one second, I'm almost done.
Okay.
If you've got like 2 more minutes. If they're in the valley, they tend to be near people. They're more apt to be near people. So like I said, they do create wind noise, but that's only within about a quarter mile of them. So if you live more than a quarter mile away, when the noise isn't really an issue, and it's sort of a you could see how like people would get annoyed with that. What else? A lot of people don't like the sight of them. Although there are some that are really small. If you guys ever go south, like just north of Corvallis, there's a big farm, and this guy has just a single little wind turbine, and that thing is just going all day long. I don't think it's unsightly at all. It's just a tiny little thing. I would
What's
imagine.
wrong with the big ones?
I want to say it's probably no more than 10 feet across, like diameter wise, probably 10 feet across. I couldn't imagine it being any bigger than that. I don't think it's a real issue. So those singular ones, not a problem. I could actually, I've really thought about it at my house. It's really windy at my house in Forest Grove. I don't know whether I'd rather do solar or I'd rather do the wind turbine. Issue with the wind turbine is I do have a lot of birds, and I would be afraid, like, wing, and they'd go into it, or the wind would be too fierce and like blow it down. I don't know. I have to do a little bit more homework. But you can have ones that are on your house. They have ones that are in downtown Portland, on top of the rooftops and stuff. Produce enough energy for most of their energy needs, actually. And when we tend to think of the 3-blade wind turbines, they have ones that are spirally shaped. They have ones that are really inconspicuous that you can put on your house. I mean, they're not just like a fan. They look almost sort of like a spiral. It's neat. It's neat what they're coming out with right now with wind turbines. If
Like
you're
they could make some that are more appealing to the eye, that are
Yeah.
different or diverse.
exactly,
With
So
pink
to-
and polka dots.
yeah. So no, you wouldn't be able to tell if they had polka dots because they spin so fast. But
I would tell.
when we talk about what is the most likely source of energy in the 21st century, people are really putting their eggs in the natural gas and wind energy basket. Those are the two. So tomorrow when I talk about it, I'm really not going to talk about biomass so much. I'm not really going to talk about coal as much as I could. Nuclear is still a competitor, but I think nuclear is one of those things where people are so scared of it. And it's a no-win situation because it's very expensive upfront cost, and then you've got this lifelong generational burden of dealing with the waste. Until we have a better way to deal with the waste, nuclear is just not a great option. And like I said, people are terrified of it. So it's still in the works, but I don't know if in the 21st century it's going to be a huge player. I could be wrong. Really, it's a matter of if we keep with fossil fuels, we're focusing on natural gas. If we focus on alternative energy sources, it's going to be wind, potentially wave. But, I mean, they just shut down the one off of Reedsport, so it's got a lot of bugs still. We still got to figure it out. But wind. So tomorrow I will mostly focus on former sources of energy and new sources. And so you guys, I know we were talking about doing math today. We'll just maybe do it next weekend. So next Sunday we'll go through some of those.
You're actually gonna come next Sunday.
Mhm.
When are you coming back from your?
On Friday night.
Ooh, what is it?
Next week I'll be in
We're
DC.
just in the.
Oh, right,
just in
right, I
Bristol
forgot.
building
That is
some
so
random
cool.
sub.
Yeah.
That would
That-
be weird.
You must be excited going up to DC.
Yeah, I'm not prepared for it though. But anyway, how about next week we'll do some of the mathy stuff. How about we prepare for next week, and that next week we'll do long division and multiplication. Make sure you guys are up to speed with feeling comfortable doing the math by hand. And as a practice integrating this stuff, we'll talk about unit conversions, and I'll give you guys, I sent it in your email today, but I will make sure you actually go over it. So maybe, since I won't be there on Wednesday you will be doing a lab on natural resources, like how cost of natural resources change as you mine a resource. You'll need to make sure you finish up that lab, which I think you could have done in probably class if you guys are really smart about it. I mean, let's see, you got an hour. No, you might have to take that home. I don't know. But anyway, you'll have a little bit of homework from Wednesday's lab. I would say for Sunday, I might give you guys a little bit of reading, or I'll give you guys those those problems that I sent you in your email today, and you guys can work on those. And that's about it. Any questions about this? Did you guys learn a lot today?
Yes.
Yeah,
It
or
was a lot.
how do you feel?
I feel like it was good.
Yeah.
Stuff I didn't know.
Yeah, now there is a chapter in your textbook on energy. So if you need to, what I would do, what would be probably really smart, is to rewatch this video with the textbook and kind of try and find it. They're going to have pictures. I don't know if they'll have fracking in the textbook. I will make sure that we talk about it tomorrow, what fracking is. But yeah, as you go through your textbook, they should have everything else, a little bit of everything else. Probably going to be kind of slim on biomass, but you should have how a dam works and how wind turbines work and coal and oil, and you can kind of go through there and kind of double check all the information, make sure that you're familiar with it. Something else that I would recommend doing is they've got some problems at the end of that chapter on energy stuff. Try and answer some of those questions. And that's the sort of stuff that you can bring into class and be like, hey, in the textbook it asks this question, and I don't really know how to go about that, or I was a little confused. That's a great time to bring it up. That's what's going to make this next month super, super useful for you guys, is if you can take that time, because you will need to put some time at home studying this stuff. Just coming to class, just coming to this might not be enough for you guys. Especially if you really don't have a whole lot of familiarity with these topics in the first place. You're kind of coming in with a deficit. A lot of these kids that are taking the AP exam, they've been learning about this stuff in previous classes. We don't have, with FPC, the way we do, a lot of our freshmen are coming in, they don't even have the familiarity with atoms, so it's really hard. And with energy and stuff, a lot of FPC is review, stuff that you were supposed to learn. In a lot of that is what you're supposed to learn in middle school. So you by taking that FPC class, a lot of you need to take it, but you're kind of down a year of science. Whereas a lot of kids, other kids at different schools may have a more accelerated science track where they take chemistry first year or biology first year. They're doubling up on science classes every year, 2 science classes a year instead of 2 math classes a year. You know what I mean?
Mm-hmm.
So you're kind of competing against those kids. So if you don't have that background knowledge, you got to kind of build it for yourself. And that's why these Sunday sessions are going to be really handy. But like I said, you guys are going to have to, I'm serious, go home, just spend 20 minutes at home tonight while it's still fresh in your head, crack open that textbook and look. And see if there's something I missed. I might have glossed over something. But, do that. And then Monday, tomorrow, you guys will be all set. I bet you'll be 100 times more prepared than some of the kids that aren't watching the video or weren't here today.
Are you going to upload it and send out an email tonight?
Yeah.
Thank you.
Yeah. All
Oh, and
right.
I want to say, if any
Hope it was helpful.
there's